a velodrome, which is built for the Olympics, and the radius of the curvature of the surface is 20 meters, so right here. At what angle should the surface be banked for cyclists moving at 18 meters per second? Choose an angle so that no frictional force is needed to keep the cyclist on their path. So right here we have theta, and I drew a little diagram. That's my bike. No, I know, bad art class. So first we're going to draw our free body diagram. So I drew, this is as my X and Y axis, and then we have gravity that's acting down, and then our normal force that's bringing the bike around. So I put theta right here, and then we're going to do the sum of the forces in the Y direction is our normal force, that's cosine of theta, and minus gravity is our Y, equals 0, which when we work out is n cosine of theta equals mg. So then on our sum of the forces in the X direction, we have n, so our normal force, that if we put theta here, it's going to be opposite over hypotenuse, so it's going to be sine of theta equals mass times velocity squared over r. We're going to use this since we're going in a circle for acceleration. Usually it's mass times acceleration, but this is where the formula we're going to use if we're going in a circle. So after we do that, we're going to do n sine of theta over n cosine of theta equals mv squared over r mg. Now we can just cancel using algebra, so our n's cancel and our masses cancel also. And then from trig, we have sine over cosine's tangent. So tangent of theta equals v squared over rg. Alright, then we're going to get our theta is the inverse tangent of v squared over rg. And now we're going to plug in our new numbers. So we have theta is going to equal inverse tangent of 18 squared, since it's going 18 meters per second is our velocity, over 20, which was our radius, and 9.8, which is gravity constant, or gravity. So theta equals 58.8. We're going to round it up. So the angle that's going to be to where no frictional force is needed to help the cyclist is going to be 59 degrees. It's going to be the optimal angle.